Hello, good morning, good evening, good afternoon. Welcome to another episode of Xah Talk Show. We are going to code Advent of Code 2025, Day 6, Part 2 in Wolfram Language. Fantastic. If you are watching this offline, play at 1.5 speed minimum. If you are here, say hi. Love to see your comments. And here is my Xah Talk Show on my website, xahlee.info, HTTP no S. So in the past month, we almost live streamed every day. And so day 6, so we're going to continue to day 6, part 2. Wait, did we? Okay, so we need to, I need to update this. So today's part 2. And did we forgot to update? So go to topics. So there. So let's go here. That's day 6, part 1, and that's the code. Yeah, so we got part 2. Okay, let's just start to code it. This is probably boring for most of you. But if you are interested in functional programming and Wolfram language, then you might learn something. Okay, so let's begin. Let me take off my jacket because it's hot. This is Mickey Mouse Nation. Okay, can you see the screen? Yeah. So part 1 problem is very simple. Okay, you got a list, you got a text file like that, and that's just this text file is separated into several columns. So you have a bunch of numbers at the bottom. There's a operation, plus or multiplication sign. Your job is to sum up all the columns. For each column, operate by that operation sign at the bottom. So for this column, you add them together. For this column, you multiply them together. So for each column, you got a number. Then you add up all the numbers. That is your puzzle solution. Okay, that's what it asks for. So we solved it the other day. Trivial. In fact, the shortest code, actually, I have this shortest code. I coded offline. You cannot see it. I mean, I didn't do it live. So let me open. I think I did live. I forgot. So let's go to Wolfram Language. Let's start Wolfram Language and let me show you. Yeah, okay, so there, and just copy that, go here. So Wolfram Language, you need to blow it up and paste the code, Shift Enter to run it. There is the answer. Okay, fantastic, Wolfram Language. So now let's go back to the part 2. Let's see what the part 2 asks for. Okay, part 2. So the first part is complete. God, this is very annoying Advent of Code. You cannot read it. Okay. So let's copy it. Let's copy it to Emacs. Okay. So open a new buffer. Now let's see part 2. Okay. Okay. The big cephalopods came back to check how things are going. When they see that your grand total doesn't match the one expected by the worksheet, they realize they forgot to explain how to read cephalopod math. Cephalopod, that means squid, octopus, those kind of creatures. Cephalopod. Cephalopod math is written right to left in columns. Each number is given in its own column. with the most significant digit at the top and the least significant digit at the bottom. So from right to left, and each number is given in its own column with the most significant digit at the top. Right to left. Okay, confusing. Problems are still separated with a column consisting only spaces, and the symbol at the top of the problem is still the operator to use, and the symbol at the bottom of the problem. Okay, so basically you got the same input. Now, reading the problem right to left, one column at a time. Okay, one column at a time. The problem are now quite different. The rightmost column is the rightmost column, so it's 4 plus 431. What? 4 plus 431 plus 623. Oh, 4 plus 431 plus 623. What the twisted shit equals to that. The second problem from the right is 175. So it's over here. 175, 581, 581, then 32. Okay. So the numbers are, okay, I think I made sense now. You see, each column, they are aligned. So first of all, they use spaces to separate the columns. But however, within each column, they are aligned to the left instead of to the right. Like typically, if you have a number, let's say 23, and you have 100, let's say 200, you align them to the right. So see, 23 or 200, you align them to the right. But in this problem, you got 64 in this column, you got 64, 23, 314. You first of all align them to the left. Okay, so let's make a Emacs trick. So let's copy that column. Okay, let's do it again. So press. You can see the command call is copy rectangle to register. Okay, then press yank rectangle. Okay. Okay, hold on a second. Press. What did we not copy then to register? Press. No. What? Okay, so what? Yank rectangle. Okay, so hold on a second. Let me do this Emacs stuff correctly. If you ask here, say hi, okay? What's going on? I'm not sure what is going on. Press. Oh, okay. So let's say 1. And press. Okay. 1. Press. Okay, wait. 1. Press. Failed. Yeah. I was trying to demo a Emacs trick, but I failed. But we can do it this way, okay? Do. Okay, that way. So anyway, given a column of numbers, they need to be aligned on the left, which they already did. Okay, so then you read. So given this column of numbers, and each one must be aligned on the left, then you consider a column as a digit column. Okay, so you go from the rightmost column, you got nothing, you got a 4. So therefore that is 4 there. And then here you got 431. That's why it is 431. Then the next is 623. Does it check? Yes, 623. Okay. Remember, each column is a bunch of digits in each row. Now, for this bunch of digits in a column, you must align each number to the left. Then you consider one single digit space as a column. Then you begin from the right. So the first column, you got just one number, or more. Then the second column from the right. Then the third column. So in other words, each column of this single digit column, they create a number. So for example, here is 4, here is 431, here is 623. Okay. Now let's check one more column. So 175, check. 581, check. Then 32, check. Then what about this one? That's 8, check. 248, check. 369, check. Okay. Now last one, 356, check. Then 24, check. Then 1, check. Okay. Then the grand total, you sum these numbers up. Then you sum them up. Okay. Then you got that. Solve the problem on the math worksheet again. What is the grand total? Okay. Okay. You got the problem? Yes. Now, commencement of solution. Shall we? If you are here, say hi, okay? Now, this is a commencement of solution. Advent of Code 2025, day 6, and let's, where do we begin? Press, begin a new section, you can see. And can you see my screen? Yes. Okay, then start a Wolfram Language code and Advent of Code part 2. Okay, so now what is the input? Well, let's copy from the previous day. We have the input here. In fact, we can let's copy this. Okay, so paste, pop it out. So we are beginning to code this. First, turn the text block into a matrix of strings. Okay, yeah, that's good. Then you extract the last row as list of operators. Then hold on a second. So a matrix strings. Then you rotate it. Okay, so you can you see we evaluate this. So you got that. Okay, that's what you get. Okay, then this is input string matrix. Okay, then you rotate. Okay, let me show you. X input string matrix rotate right. Okay, you can do that, but let's evaluate this in Wolfram language so that we can do this sequentially. Select all, paste, shift, enter. There it is. So you can see we rotate left. Rotate left is just like rotate each element to the left. So the rightmost item, the last item, now become the first. This first becomes second. So you see, that's a result. Beautiful. Elegant. So the reason we want to move it to the first is because so that we can apply, because it's a column, right? We can apply, anyway. Then what we do is a transpose. Okay, let me just do it. Show you. Transpose at that. Okay, let me just run it, and the result will make it clear. You see, it transposes the matrix. Fantastic and beautiful. It is. Copy. So let's show the result here. So that it is clear. Okay. So now we got that. What do you do with this? Now, for each number, you want to consider it as remember, it's a column of stuff. It's a column. So 1, 2, 3, 4, 5, 6. Let's go back here. So let's consider you see this, you don't need this. So for each number, you want to, okay, so this is, that's interesting. So basically, what you can do is you add zeros to those numbers that does not have enough digits. So first of all, you find out what is the maximum number of digits. Okay, let's say 10. Then for the rest of the numbers, you pad them to the right until they have 10 digits. Then you can take this like digit rectangle, then transpose again. Would that work? No. Because if you do that, then you got 400, not 004. So yeah, so you have to pad. Okay, so besides, even if this works, it's not a good solution, because then you need to take each of these column of digits. They are column of strings. You need to pad zeros to the string. Then for this list of strings, then you need to turn that into a matrix. Then you do transpose. Then okay, so that's one idea. Let's think about the next idea. That's one idea. Okay, if you are here, say hi. Hello, Amar. Very cool keyboard. That's Ultimate Hacking Keyboard 80, UHK 80. I have video reviews and unboxing. Each one is 1 hour on my YouTube. So search for it, you'll find it. Or search on xahlee.info. You will find my full textual review and photographic review. Lots of fine photos on each and every detail. Okay, I recommend it. Fantastic keyboard. Okay, back to this problem. So so you got the list of numbers. What do you want to do with it? The part 2 is a more annoying problem. Okay, So ultimately, you have to find out what is the maximum number of digits in a column. Like the question is it necessary? Is that a necessary step to solve this problem? I think the answer is yes. For each column, you must, whatever algorithm you do, you need to find out what is the maximum number of digits in each entry in the column. Why do you need to do that? Because wait, hold on a second. So let's just focus on one column, okay? For example, focus on this last column. So just imagine in your head you have lots, several numbers. They are all aligned to the left. Now, these are not real numbers because you need a special interpretation. These are not what it seems. They deceive the eye. Do you guys see what I mean? For example, that column. Now let's do the Emacs trick again. Okay, for example, this column. That's not the numbers. The real numbers is 4, 4, 3, 1, 6, 6, 2, 3. You see, that's a real number. That's a real number. Turn to the mathematics real numbers. Anyway, so you need to turn that into that. Okay, so you have to think about it. Okay, 446. 446. 314. 431. Now, if you pad 0, let's think about this, okay? If you pad 0, what would happen? That's not right. So first of all, 446 or 644, there's a pattern. Do you see it? No. So okay, so what if you pad to the right? 004, check. Okay, so you have to pad it to the right. Tedious. Now the problem is, I think I know how to solve the problem, but the problem is thinking about efficiency, like what kind of approach you want to do it. So this, you can pad it, sure. And also make sure does padding also always work? Does it always work? I think so. So anyway, if you pad to the right, then you got 4004, then 431, then 623. Okay. Now if you pad to the left, doesn't count. Okay. So so if you pad it to the right, then you can do a transpose. Yes, you can. So it turns out maybe that is the best approach. Pad it to the right. So first of all, find the maximum number of digits. Then pad it to the right, a 0. Then turn the whole thing into a matrix. Then do a transposition. Then convert each string to a number. Then just add all those numbers or whatever, multiply, according to that. So let me think about again, okay? So you given this, so but since you are already since we already did a transposition, let's see how does this work out? 1, 2, 3, 4, 5, 6. 46, 23, 314, 46, 23, 314. So that went to there. Okay, so for this 46, 23, 314, you want change 64 to 640. Okay, then 23 becomes 230, then 314 becomes 314. Okay, I think I got it. I got the solution. So let me think again, then one-shot coding will solve it. Okay, this is already transposed. Then you just take the rest of the list, then find the maximum. Count the number of digits, then you pad for each and every. Then this list of strings, you change them into a matrix and you transpose, and then you turn each number into each string into a number. Then you sum it up according to the operator. Then you sum it up. Okay, I got the solution. Let's write it up. The algorithm description. Again, if you are watching this, play it twice as fast. Okay, something like that. Okay. Algo description. For each row, find the max number. Find the max length of string. Max number, which is max length of the string. Okay. Then for each number, pad 0 by the max length. Then consider all these numbers, turn it into a matrix. Each element is a single digit. Then Oh, tedious. Turn them, then you each is a single digit. Yeah, so you need some kind of illustration like here. This we remove. So this cut. You need some illustration. Okay, so now should you okay, consider this column. Okay, then let's go into detail so that it's slow, but we have clarity. We already turned it into a list like this. Okay, so we want to add it like this. Okay, and read each single digit column from right, and for each single digit column starting from right, turn it into a number so that we have. Okay, so this part is kind of the description of the problem. Once you get that, then it becomes easy. Okay, so let's move the description of the problem into the talk show. Okay, there is the description of the problem. Now this is kind of tedious. Yeah, to do this, you have to find the maximum number of digits in each column. Then you have to pad all the rest. Tedious. Is there a better way? Isn't there a better way, my friend? Nobody's here? Okay. Oh God, advent of code getting tedious every day. Solution. Coffee. This is fantastic. Rich honey and milk and instant coffee. Let's go back to the Argo description. Okay. Now, we can code this in a single line, this Wolfram language. We can make it into a single line, but it just takes some time. Okay, 20 minutes. If nobody is looking, I'm going to finish this in 20 minutes. But I need to talk. Okay, well, I'll try to do fast. Let's try to do fast. Okay, Argo description. Then find wait, actually, and let's just be short, okay? For each number, pad 0 to the right. Pad string 0 to the right. You need explanation. Is it tedious? So we got that, okay. Then consider all these numbers, turn it into a matrix. Oh God. So what you get is that oh God, this is very tedious. So let me show you what's going on. Wait. Okay, so that's what you get. Then we do a transpose. And what is the transpose? You get that. Okay. Then join string. Into a number. Join string and turn it into a number. So what you get is that's right. Then just apply the operator to these numbers. Okay, that is the complete illustrated algorithm description. Perfect. So let's copy it out. Separation of concerns. Put it into a different description instead of code. So show in browser, go down. So here is this description of the problem. Fantastic and beautiful. And then we have algorithm description. Now this algorithm is particular to Wolfram language. Because we are using this kind of Wolfram language features, But if you are doing this in JavaScript, good luck. Or Python, you don't do this. You don't necessarily do it like turning into a matrix. Then, yeah, I don't think so. You just do loops, lots of tedious loops. But okay, let's push on. Okay, now I got the detailed algorithm description in my brain. Now let's see if we can just code it in one shot. Please, God, help me. If you are here, say hi, okay? Now, Provident, wish me good luck. Begin coding. Okay, so we're gonna do this one shot. Can we do it? Yeah. You don't want that. Okay, so let me try to code this in one shot. Now give me 20 minutes, okay? Let me just try to code this in one shot. Oh God. What language should I learn if I aim is to flex on other people? That would be Wolfram Language. Okay, so operators include in is that X matrix. Let's see. Let me just do a lot of temp variables because that kind of is very helpful. Okay, so I got the matrix, I got the operators. Now the matrix, for each you want to find the max length. Let's see the documentation for max. Okay, that just return the largest. Now I want a function maximal by. Okay, maximal by is available in 2014, about 10 years ago. Will I use it? Yes. Okay, max by. So you got a matrix, then you want maximum by string length. Let's just do that, okay? Max by. Let's not do one shot. Let's, otherwise, because then if it didn't work, then I have to debug. Let's, run a code meanwhile. So, oh, that's not it. What? What? I thought drop. You see, we already got arrow. Drop. Oh, you don't want drop. You want most. Okay. Wait. You want the last or most? Operator is drop last. What? Let's see. Documentation. Drop. You want to drop the last item, but is there a shortcut? Yeah, that's the most. Okay, that's our matrix, and our operators are those 1, 2, 3, 4. Did we transpose yet? Nah, shit. This. Okay, really, I need to focus. Okay. We did not transpose. We did not transpose. You need to do that, my friend. You forgot. Oh, yeah, we did it over here, but okay. Do it again. So that's the matrix. Yep. 1, 2, 3, 4, 5, 6. So we transposed, okay? It's just okay. Then we can execute this. That returns 1, 2, 3. Okay. Then you just string length add. Three. Okay. What? Oh, maximal by. Why is it return a list, not just a number by itself? Okay, because there might be more than one item. So if you say max, what is the default way they compute maximum if you have a bunch of strings? Indeterminate way. Okay, so when it's strings, it consider indeterminate. It return itself. But if they are numbers, they return a number. So you don't, okay, so you don't want the max, okay? You want the maximum by. Okay, maximum by, it return a list of multiple values. Yeah, I don't want to use max by. Okay, let me just use let me just show you, okay, what to do. Map length by, that's the least, map string length and the max. Okay, that's much simpler. Run it. That's much simpler. I don't want the maximum by shit. Okay, so cut that. That's an example. Okay, so this is how you get max. Okay, now you simply apply. Okay, so now apply, you want to map a function to X matrix. Okay, now what does the function do? The function will do something like that. Okay, now the function takes X is the argument, then here is X. Okay, that returns the maximum. Then okay, let me put it into a local variable. Okay, max length. Then what you do, then you map again. You map string pad. String pad, right? That's right. X, you want to pad by 0, and you want to pad by max length of times. I mean, the total should be max length, something like that. And map that to, yeah, to each number, which is this X. Now, you need to find out what exactly is the parameters for string pad, right? Okay, make string to be length n, padding it on the right with spaces or truncating if necessary. Okay, so we got the syntax reversed, so this max part should be here. Perfect. Map this function with a local variable of the maximum number of length in them. Then you just pad it to that much. Okay, so once you do this, you got each of these, you can run it. Okay, let's run it so it's clear to everyone what's going on. Okay, error. That's not what I wanted. You got a problem? did we have our matrix correct? 1, 2, 3, 1, 2, 3, 4, 5, 0, 600. So we did pad. But what is this? Okay, we got an error somewhere. Map to the matrix, right? Oh, right. So map to the matrix. Each X is a row. Right. So let's name it properly. Let's make it row. Okay. That's a row. And then you map that to the row, and oh yeah, that's right, this part should be a function, not that. Okay, so this part should be a function, please. That's what the function should do, and the X is that number. Let's just say num. Okay, make it simple. So this copy, go back here, paste, execute. Fantastic and beautiful. You see how aligned they are. If you are here, say hi. Okay, beautiful, fantastic and beautiful. You see how aligned they are. Now all you have to do is for each of these row, you turn that into a matrix. Then you transpose it. 1, 2, 3, 4, 5, 0, 600. Wait, 1, 2, 3, 4, 5, 0, 600. Tricky. You see the first column, they are not aligned to the left. You see this sneaky advent of code. You see the last column, it's aligned to the left. That's what we wanted. But the first column, they did not align. But that 6 is become 600. Is that right? That 6 is 600 somewhere. Somewhere, please. What? No. What? God. Don't tell me I'm wrong. Wait, so, part 2, what? So align to the right. Oh, wait, it's... Oh, you cannot turn that into 600. It's just 6. What? Oh, they are aligned to the... What? Okay, our algorithm now is incorrect. What the fuck? 6, 2, 3. Now then okay, then you got 175. That's this one. Then you got 8, 248, 8, 248. Oh, you cannot pad 0. You cannot pad 0. You must pad it like space. You can't pad 0. You pad it with a space. Okay. And the first column is what? Then you got 3, 5, 6, 24, 1. Wait. Oh God, our algorithm is incorrect even. And it seems now that we don't understand the problem. The 3, 5, 6 there. Okay. Can you see that? Three, five, six. So where do they align? Wait a minute. This alignment is funky. Reading the problems right to left, one column at a time. Okay, so the problem is really tricky. You see, these columns are separated by space, but however, the number of spaces has significance because what's considered a number is dependent. What is considered a number, whether it's one single digit or whatnot, is dependent on this spacing. Shit. But I think that actually makes the problem easier. So we have to remedy. So we got it wrong. Remedy, realization. Okay. Realization are previous understanding of the problem is incorrect. This needs to be a header. Actually, the given input text there spacing between the number of spaces between columns is significant. Realization. The given input text, the number of spaces between columns is significant. I think this actually makes the problem easier, but I'll get to it. Okay, let me tell you. So text. So you can see, look at the first column. And the last column. Okay, look at the last column. In the last column, every number must be aligned to the left. But in the first column, you can't align it to the left. You can't do this align yourself. You must follow what is already given. So in the first column, they actually are aligned to the right. So you got 3, 5, 6, 2, 4, then 1. Is that right? You see 3, 5, 6, 2, 4, and 1. Okay, so that actually, now let's go back to think about our algorithm. We wasted our time doing this already. We wasted 1 hour already. So now the new problem. All you have to do is you need to keep the alignment, okay? Now this tedious shit, you need to keep the alignment. Now let's look at this. Alignment is significant. You see, if you just split a string, like usually programmers do with their programming languages, then you lost that information. You lost the alignment information. Should we write it out? Full analysis. If you just split the string like most for each row of text, you lose the alignment info. Very nasty. So how can we keep the alignment info? Okay, go back. So this advent of code, they like to treat, so again, you have this kind of grid, like a grid puzzle thing. You have to move a cursor around it. How do you, so this becomes a problem. What kind of problem? What kind of category of problem is this? So you see this text file, this input text, you must treat it like you need to find out, so all the columns. So first of all, like you have a comma separated value or space separated value, right? Oh shit. So you have to keep knowing. Okay, now let's look at our personal input. Okay, this is becoming a great problem. You see, this is one line, that's one single line. Then this is the second line. Can you see it? Okay. This is the first line. Okay. That's one long line. You see, but look at the spaces. They are significant. So what you can do is you can actually split by space, but you split by a single space. No, that won't work either. So this problem is designed to screw the industrial programmers. You see, because it's treating, you got except Emac Lisp coders, because you put this text in a buffer, Emac Lisp can navigate it. But if you split a string, you run into problems. Unless you split and you want to keep the splitted part, that you can do in most languages. But that means for each number you have to look. So you got an issue. You have to look the previous spaces or the spaces after. For example, the number 6, you have to look at the spaces before. Now the number 98, you have to look at the spaces after. Okay. Okay, let's make sure we understand this problem. Cephalopod math is written right to left in columns. Right to left in columns. Each number is given in its own column, with the most significant digit at the top. And the least significant digit at the bottom. Yeah, so this is actually becoming a tricky problem, actually. Not, I don't. So, okay, a new approach. Now you take this input text, you remove the operators row at the bottom. Then you turn it into a matrix, except that this time you keep all the spaces because spaces are important. Okay. Then so consider this text. Okay, consider this text where each character width is a matrix element. Okay, so that then you can transpose the entire matrix. Then you just read off each row. Okay, so you got 4, 4, 3, 2. I mean 4, 4, 3, 1, 6, 2, 3. Okay, then you got a row of empty spaces. Fantastic. Then you got 175, 581, 032. Correct. Does it check? Yes. Then you got a row of spaces. Every element in that row is spaces. Okay. Then you got 8, then 248, then 369. Check. Fantastic and beautiful. Now this algorithm. New revelation. Let's write it down. Since I'm already like 1 hour, let's just go all the way. Keep my style. Ching ching, Oflamio, thank you very much. Not a waste. You learned what doesn't work. That's true. Fantastic. Thank you, Oflamio. Oflamio, I look at the problem. They look like stacks. Stacks. Not in the computer science sense of stacks, but I mean they are kind of like stack of numbers. But anyway, we got a solution. Okay, so realization. Okay, so now after realization, okay, now let's write down our thoughts. New algo, fantastic and efficient. Consider the input text as a matrix of single chars. Okay. Turn the input text into such a matrix. Each element is a single char or single digit or single space string. Okay, fantastic. Then transpose the matrix. Then turn each row, transpose the matrix, then okay, then remove rows that are all empty spaces. Okay, then turn each row's element from string to number. Then sum each row. Not sum, apply the operator to each row to the corresponding row. For each row, apply the operator to the corresponding row. Then total them. Fantastic and beautiful new algorithm described here. Okay, so let's do that. Okay, okay, let's copy that. Let's not destroy. So let's do that. Okay, first turn the text block into a matrix strings. Each element is a single char. Okay, so let's do that. Okay, so then first of all, split string by the line break, then function line strings split string by you don't want to split string, you want to turn, let me show you what to do. You want to turn this into a characters. Okay, that's it. That is a function. Okay, you'll see what it does. You see, fantastic. So it turns a string into each character. Okay, each one of these are strings. Okay, that's what you want to do. Okay, so instead of split string here, this function, you just say characters. Yeah. Okay. Okay, let's put that example. Let's put that example here. Okay, then go back to our code. Okay, so we can run it. Cut, paste, run it. Fantastic. So you get that. Copy. That's what you get. Okay, it's ugly. Then do a transpose. Actually, let's just do transpose here. Actually, just wait, something is wrong. What? the first two levels cannot be transposed. What? Oh, because you got this, you know, that's the problem. Okay, so copy that, shift enter. What? What? So how many characters there? What? Fourteen. Oh, 15. You see so you see, so you see, so you cannot truncate lines. I mean, you cannot remove the empty space at the end. So let's see. So if you carefully copy this input, let's see if they have spaces at the end. You see, because my input I may have already truncated, because every time I save the file, it removes the spaces at the end of the line, because that's common, you know. So if we paste it here and show, you see, carefully, this sneaky advent of code, they do have a space at the end. So it's not what it seems. You see, space usually doesn't show, but but they actually include a space at the end to like secretly show you to those who know. Okay, because if you don't have the ending spaces, this puzzle won't work, because then you are well, actually it still works. You just have to manually pad them. Yeah, so first job is you have to find the longest length of line. Then you pad space. Yeah, it's tricky, okay? So you see, very tricky shit. Okay, so but now if you do this, you know, now you do this, it'll work. So shift enter. Okay, then you go back here, then you want to transpose, paste. You see, now it works. Very sneaky thing. So what we got? Oh, you need to remove that. What does this transpose to? What is this number? Wait. Let's see. Did we? Okay, so okay. Select all, paste, shift enter. Why is the operators got all moved about? Wait, now I don't understand. Okay. 45, 6, 3, 5, 6, empty. Okay, so every time you have a empty, so let's do this again, okay? So every time you have a empty, okay, and you got empty again, empty, empty. So you see, you got empty, so so 1, 2, 4, 3, 5, 6. 1, 2, 4, 3, 5, 6. Now 3, 6, 9, 2, 4, 8, and 8. 3, 6, 9. You see, 3, 6, 9, 2, 4, 8, and 8. Fantastic. Then 3, 2, 5, 8, 1, 1, 7, 5. 3, 2, 5, 8, 1, 1, 7, 5. Fantastic. Then 623, 431, and 4. Check, check, check. Perfect. Okay, so perfect. Okay, perfect. Now those are just bad. Those are whatever before. Let's remove it. Okay. Just be careful. You cannot. Let's make a note. Each trailing line in input may be spaces. If you delete them, it won't work. Very careful. Okay. Now let's look at the input, our text input. I mean, our puzzle input. You know, there may be spaces that I might remove it. So I have to like make sure I get the input. There is a space. You know, the spaces at the end of each line, you cannot remove them. If you do, then you have to find the maximum number of characters in all these lines. Then you need to pad space for every line. So you gotta be careful about that. So now, back to this, okay? So now, so far so good, yes. So far, this is what we get. Okay, copy it. Okay, this is not showing well, okay. Yeah. So now you just have to almost done. Almost. Now it would be nice if you remove the operators. You see the operator symbol is like, where are they aligned? They are aligned in arbitrary places. No shit. This is closing to 2 hours. Oh God. So any comments? Comments? No comments. The operator is always the last line. Okay, so let's spare the operators. Okay. Huh. Let's try this again. Paste, Shift Enter. Yeah. You see, I removed the space. Is there a way so I stop remove? You see, because I have I have my code set up so that each time you put it back, they remove the trailing spaces. If each time you put it out, they remove the trailing spaces. So that's a problem. You can, and so what you can do, this is very annoying. Okay, so you can just copy it. Then you got the spaces back. Okay, very annoying. Now copy that. Now you paste the code, Shift Enter. Fantastic. You can see now it's much more simpler. Now all you have to do is split. Join string. Okay, hold on a second. Join string. Okay, so operators. Matrix equals to that. Fantastic, fantastic and beautiful. Then you want to split this. Okay, almost done. 20 minutes max. Then you want to like split string or partition. Okay, or split by. Let's see, split by is from 2008. That's good. Now split is from 1996. Okay. Now let's split by a function. Split list into sublist consisting of runs of successive elements that gives the same value when f is applied. Okay. Okay, I need to finish this quickly. Okay, I need to finish this quickly. It's getting too long. Okay, I'm gonna take a break, 5 minutes. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I'll be back at 16:50. That means like 10 minutes. Now, right now it's 4 o'clock 40 minutes. So I'll be back at 4 o'clock and 50 minutes. I'm going to try cheeky LibreOffice trick on it. Please, Oflamio, I would be happy to see you solve this problem. I'm treating input as CSV file and then treating as fixed length field. Fantastic. But you might be careful because if you treated the input as CS file, comma separate file, you have to treat it as space separated. Actually, I'm not sure Excel or LibreOffice has that feature because this, you see, that's a tricky part. You can't, the input, you can't just split it because when you treat it as comma separated, there's no comma. So you have to treat it as space separated. But if you do that, you basically will be removing the spaces. Then you cannot solve the problem because the spaces are important. So you have to read them as kind of like a line without removing any space, including the space in the end, trailing spaces. Yeah, I don't know how you solve that with Excel or LibreOffice, but try it. But we are almost done. Okay, let me just take a 5 minutes break. I go to the bathroom and stuff. So how many people are watching? 3. Let me make a guess. 4. Oh, Flaming, I'm treating it as neither as comma or space, nor space. New line separated, yeah. Let's see how it goes. Okay, I'll be right back. Let's turn off this sneaky cam. Okay, I'm back. Turn on my face, and let's make a change to the input. Okay, change the input text by replacing spaces to dots. Okay, that way we don't have this that way we don't have this trailing space white space problem. Okay, so now it's simpler. Now go back to my personal input. Let's make the same change. Okay, so let's copy the personal input, and let's see, where's my personal input? Get select all, copy, close, back to Emacs, select all, make a backup, paste, go to the beginning. You see, that's why you see the last character is a space, tricky. Now go to the beginning, change space to dot. Okay, wait, change space to dot. Okay, ban to do it all. Okay, now save it. Okay, we made a change, so now it's actually, so now you can clearly see the space. Close that. Back to our code. Okay, now now we don't have to so now we can do this. Okay, so now we go back to Wolfram Language, select all, paste, shift enter. So now you can see actual spaces. Okay, input matrix becomes that. Okay, and the operators become that. Wait, what? Copy, paste. Why do we have a operators? Select all, copy, go back, paste. So you got this continuation line mark. Why is that? I don't understand. I mean, you got this backspace. Backspace usually means continue the line, okay? But what? Okay, so okay. Then matrix become, why do we have the sort? Where is the sort? delete that. Okay, delete. So copy all, select all, paste, shift enter. Okay, the matrix becomes this. Okay, so it adds the line continuation. The matrix becomes this. Okay. Now, split. Split by X matrix by a function. The function will do string contains. Okay, X, that's a string. If it contains zero to 9, okay? Regular expression. Okay, regular expression 0 to 9. You need them in square brackets. Okay, split the matrix by the function. If it matches regular expression 0 to 9, so that means this is true, 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 false, true, 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 false, true, 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 false. Let's see. Paste, shift enter. Yes, fantastic. Now copy the output. Copy back to Emacs. This is the result. Okay. So now we get a clear, you can see you get that. Okay, now let's assign it a split matrix. Let's just say equals true. Okay. Back to Wolfram Language, evaluate it so that it knows that value split matrix. Okay. Fantastic and beautiful. Then the solution is almost there. Then you just delete cases. You want to delete cases. Okay, in this example, it's 3 dots, but in personal input, it might be more than 3 dots. So you want to delete cases by it's a pattern. Okay, so you want to apply a function delete cases Right. They should be, so those elements you want to delete have length 1. So let's say select instead. Select, and then you also have discard. Discard criteria removes all elements of data for which criteria is true. So you can use discard. Discard is added in 2025. Okay, I don't want to use that. That's actually I don't have that function because I'm not using, my Wolfram language is like 1 or 2 years out of date. I haven't updated yet. I can, but I just haven't done it yet. So let's just use select. Okay, select, split matrix, select from that. Now function, if length at x is greater than 1. Okay, let's do it. That will remove those ... elements. Shift enter. Fantastic and beautiful. Now let's go all the way. Naming long characters. Okay, empty row removed matrix. Okay, so copy that. Oh, what? Copy that back here. Select, 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 paste, shift enter. Fantastic and beautiful. Copy that, copy back to Emacs, paste. So this is the result. Okay, so we have clarity. Each step we show the result. Now, for the empty row removed, all you have to do is apply map to it. What do you want? Map a function, of course. And what you want to do with it, for each row, you need to map again. Map, replace the dot by 0, then turn it into a number, then just sum it. Okay, map, recursive map, nested map. Okay, x. So this x is actually row. So why don't we name it so it's easier to read. So what you want to map to each row? A function, of course. What this function will do, this is string. Okay, now it will replace string. String replace. There it is. Okay, then for the string, what you want to replace by, you want to replace dot by 0. Okay, then so this replace dot by 0, then so this is a row. So for the row, you replace dot by 0. So you got a list. Then you two expression. turn them into numbers. Then you don't want to sum because you may want to multiply or sum depending on the operator, okay? But let's do this now. So this will give you a bunch of numbers, okay? Number matrix equals to that. First of all, let's see if it works. Paste, Shift, Enter. Fantastic and beautiful. Wait. Oh, you want to remove the dot by empty string. This is tricky. Yeah, you don't want to replace by 0. You want to replace by empty string. Cut, paste, Shift, Enter. Is it fantastic and beautiful? Yes, it is. 124,355. 124,355. 369, 248, and 8. 369, 248, and 8. Fantastic. And the rest we don't need to check. Okay, so this will be one single line number matrix. Okay, then we just, okay, let's copy the output so we know, so that we have clarity. Okay, then all you have to do is apply the operators to each of these rows. So the length of operator is equal to the number of rows. Let's see, 1, 2, 3, 4. So you can see, double check, length at X operators. 15. So you need to do the same split of the operators. Yeah, okay, so you need to like, okay, operators equals to, so actually we can fix it there. So operators equals to, and select select this thing by a function. Now, if string string equal wait, what? So if the string contains dot, let's do this, okay? Same Q, yeah, we can do this, dot equal dot. It'll return true, right? Because it's the same string. So what we have to do here is that equals to X. Okay, delete that. So the operators select, we can run it and see if it works. Oh, if it is not equal, so you want to equal ban. Fantastic. 1, 2, 3, 4. You got 4 elements. 1, 2, 3, 4. Match. Correct. So let's change this. This equal ban equal is the full name of that operation is SAMQ. Okay. So just for clarity, let's change it so that you can see clearly the Wolfram fully nested syntax. Do I make sense? Do you see this line and that line is equivalent? Okay. This is the syntactic power of Wolfram language. Okay, so when you run this, paste it, run, you got that. Copy and show result here. Okay, so now we remove that. Okay, now we got the operators clear. Now you want to map thread. What do you want to map to? You want to map to something to the number matrix and the operators. You want to map to these two lists in parallel. And what do you want to map to? A function, of course, always. And apply, you want to apply something to x. Oh, this function needs two parameters, x and y. So this is xop, operators, matching that part. And this is x num row. Let's say num list. Okay, fantastic and clear. So you apply the op to the num list. Make it one line, copy it back to Wolfram Language, paste it, and see if I got it correct. Now, wait, the xnum matrix, why is it blue? Because we forgot to assign it. Yeah, we forgot to assign it. So let's assign it. Paste, Shift Enter. Now it is no longer blue because it's got a value. Okay. So now you run this. Paste, Shift Enter. Incorrect. You got something wrong here. What? Oh, because you need to turn that. This operator is right now a string. You need to turn that string into plus or times function. Okay, so let's make a modification to our operators here. Okay, so before, we do that, select input string. So that part, this part, we change it by doing a replace. Okay, so that replace all of this expression, we want to replace a list of things. I mean, a list of rules. The first rule is if it's that, turn it into times. If it's a plus string, turn it into plus. Let's see. Yeah, you need to capital. Okay, can you see that? So this replace all, we'll replace that, and we don't need the paren. Okay, then does that make sense? Am I clear? So let's try it again. Fantastic and beautiful. Comments of Flamio. I'm trying to figure it out from the case with clean data by manually removing the white space after importing a CSV with spaces as delimiter. We'll figure out how to automate. Okay, I'm not sure that will work. You cannot remove the space. I don't think so. But let us know what you find out. So operators. So the result of that is this thing. each of the time plus is a Wolfram Language function name. Okay, so delete that. Okay, now the operators. Now jump to this part, copy, and let's run it. Shift enter. Fantastic. And all you do is now just total. Total at last output 3263827. Is that correct? 3263827. Correct. Okay. Finally, now how long did we take? 2 hours and talking. 4, 5, wait, 3, when did we start? So it's like, yeah, 2 hours and 20 minutes. Not too bad. So anyway, so copy the result. So copy back to Emac. This is the final result. Fantastic and beautiful. Okay, so put the code back, cut it, paste again. Now this time we're gonna try our personal input. First of all, syntax color the whole buffer, show in browser. So this is our fruit today. We started wrong description of the problem. We've failed to understand it correctly, but we didn't know. Then we started algo description, which is incorrect algorithm. Then realization. Our previous understanding of the problem is incorrect because the spaces are significant. The new algorithm, fantastic and efficient. So we consider each input text as characters, not as space-separated list of numbers, as just each single character. Then we do transpose and so on. So we got the code correct. Now we just need to try the personal input. Okay. So the personal input. So let's try it. So go to open last closed, copy, close. Now pop the code out. Now this is gonna paste. So this is big and the fantastic personal input, big mega number of lines. Okay, and we run the whole program. It should just work. Just run it in Emacs. So we got a number there. This is our new number. Is it correct? I don't know. So copy it and back to advent of code, idiotic layout, because they do fixed layout. Okay, now answer, paste, submit. That is the right answer. Yes, of course. Fantastic, solve the problem. Question, user says, how do you find writing on a split keyboard versus a traditional one? That's what kind of question is that? The basic keyboard question about split keyboard. Well, so split keyboard is better, okay? Okay, here's the answer to that question. If you do not touch type, and if you are young, you don't have any problems with your hand, you don't touch type that much, or you don't have problem with your hand, then the normal computer keyboard is just fine. Okay, it's fine. It works fine. But if you type a lot, I don't know if you are a writer or if you are a coder, you join the startup, you happen to type a lot, or you are a gamer, you chat all the time, or you are a Twitter keyboard warrior, you have to correct someone on internet, you type a lot. And you started to notice, after a few hours, your hand feels weird. That is when you want to start to look into split keyboard. Can you see my screen? I mean, you can see my keyboard, okay? So that is when you want to look into split keyboard, when you feel hand discomfort. Because split keyboard, first of all, you don't have to like put your hand like that. It's like wide shoulder length. Then they are tented like, instead of flat, they are tented. So your wrist is more in a natural position, not like that. One of the torture method is just put your hand like that on the desk for 8 hours a day. You'll feel it. Of course, you are not gonna put your hand just like that 8 hours a day, but I did, because I'm one of the weird character. For 10 years, every day I spent so much time on a flat ergonomic keyboard. Okay, it's ergonomic, it's also split, but however, it's flat. So that started, you have this kind of flat problem. So that's called pronation. Wait, is that called pronation? Yes, I think so. So that's when you want a tented keyboard, like this one. Ultimate Hacking Keyboard 80. I have a video on YouTube. Okay, watch it. Review. I hope that answered your question. Flamio says the function's easy, but the input needs its own parser. The problem says that there is a bigger data set. That's right. So good luck. Keyword equals to enroll. Good luck, Flamio. And we finished our problem today. Fantastic. I got a gold star. Thank you very much. So I'm done. Okay, so what? Okay, so I'm done, and well, I could take 5 more minutes to compact the code, because right now you see the code. I can do it in 5 minutes. I can make the code into one line. Should I do it? Let's do it, okay? I feel like I have time, so copy, and let's make the code into one single line. That is the paste, pop it out, remove the comments. I don't need all the comments anymore, and remove all. Okay, remove all the comments except the answer. Okay, now let's start to like make this whole compact. First of all, each of the variable is like used once. If it's used once, you don't need it separately. You see, for example, this matrix, this input matrix. So this matrix is used only once. Cut it, paste it there. Okay, so you don't need that. And split matrix is also used once. So if you started to compact all this into, then it becomes less readable. Okay, you don't need that anymore. Then this empty. Yeah, okay. I'm not doing, this is not the right way to shorten the code. I mean, if you are, it's not the right way, because if you do that way, you can make the whole thing into one line. But however, it becomes unreadable. Okay. For example, remove that. And the operators, you don't even need operators. The operators, you can also cut it, just that. Okay, don't need that. And then you got two. What about this one? This one is also used. Okay, so you can cut and paste it there, so it becomes this rather unreadable. And so you got only input. The input, you see this input matrix, string matrix. Actually, there's more. So, but anyway, this variable is used 3 times. I mean, 2 times. Okay, you can remove it of course, by pasting this code into two of those places, but that would be inefficient because you are doing computation twice. So what you can do is better is to create a local variable, okay? So what you do is width, okay? Then cut, then you are creating a local variable there, okay? Then this whole thing, cut, is the expression, okay? Cut. Can it work? Yes, I'm pretty sure. Run it. You see, 3263827, correct. Okay. And then, so with now this, you can, this is still unreadable. Okay. So, but the input is used only once. So you can put the input here, it's only used once. But if you paste this in Wolfram language, actually, this is not too bad because in real life, I used to code a lot like this. The way to understand this kind of code is that you must know functional programming well. So you focus on the function. So for example, you can see this structure. This is just total of this expression. You see, it's very structured. Then what is this expression? Map thread. It just takes two arguments. So the first argument is a function there. Okay. And what does the function do? Simple. It takes two arguments and just apply the operators to the list of numbers. Very simple. Okay. Map thread. Then what is the thing that you want to map to? That's this one. Okay. Now, because it's map thread of function of two elements, then this whole part is a list of two things. So the first thing is a list. That's the first list. This is the second list. Okay. Now, what is the first list? Well, you select takes a list and a function. You see, then you see this list you generate. That basically that's operators. You select from the input string the last row of the input string, which is a bunch of plus or multiplication sign string. Then you replace the multiplication by times or the plus string by plus. So they became Wolfram language function symbols, times and plus. Then you select, then, if in this last input, they got a bunch of like dot, you want to remove them. So if it's a dot, remove it. So only if it's not a dot, keep it. So basically, you just have a list of plus and times. So that's the first list of operators, which is you can see, which is this. You see, plus and times. Then the second list is, again, you dive into, you map a function, you map takes two arguments. The first one is a function. The second one is a list. So this is a list. So that's how you take it apart. So this code is actually not too bad. So let me copy that. So because in Wolfram Notebook, it formats it. But my Wolfram Xah Wolfram mode for Emacs does not format it. So if you paste the formatted code, you can kind of see it's better. Okay. So let's just delete that. Okay. Let's just input, delete, and paste that there. So run it. Still works. Yes, of course. Okay. Put it back. Syntax, color, everything show in browser. So that's it for today. Thank you guys for watching. That's kind of fun 2 hours, and I'm lucky because I'm energetic, because when I'm tired, this is not gonna be done. Okay, we got an error, this pre-class shit. Undo. Okay, so redo, refresh. Okay, that's fixed. Okay, showing browser. Yes, it's valid HTML. Good. Bye, guys. User, thank you for the stream. Thank you for watching. Next line of input and see if it works. Wait for next line of input. What do you mean? Okay, bye, guys. Fantastic.